Thank you all for being here today. So in this session, instead of talking a lot, we will give some demo of some new cool features in the 4.19 release of Apache CloudStack. Myself, Jithin, and Vishesh will be demonstrating 4 features altogether. What we have today, we have disaster recovery as a service using the core feature snapshot, copy, and destination selection, and CloudStack object storage framework, and CloudStack DRS, and VM scheduling. After the demo of all these 4 features, we can have a discussion about all of them. So I'm working as a cloud architect at Shablue. I have been involved with CloudStack since I joined Citrix and the support team there. Then I continued with at Accelerate. Recently, I joined Shablue and currently more involved in the community as well now. So about the first feature. So I would say this is the most cost-effective feature in the CloudStack in 2 ways. One is the disaster recovery as a service that we get from most of the commercial vendors are very costly. So this is a very cost-effective alternative of that using by copying the snapshot of your virtual machine volumes from in one zone to another zone. In the other I would say this is cost-effective in 2 ways. The other way is the effort that is required to develop it and the value that we get out of this feature, that is pretty huge. So if you have used CloudStack, in CloudStack we had this feature already for many years. When you register a template, register a template or upload a template, you could register it to all the zones that is in your deployment, or you could copy the template from one zone to another one. So in 4.19, what we have is we have applied the same design and principle to the snapshots. So using that, when you take a snapshot of a volume, not just you can store in the source zone where your virtual machine is located. In addition to that, you can copy this over to a remote zone as well, not just one, more than one as well. So let me show you how this works. Suppose that I'm a system admin of a company, CloudStack company, and I'm responsible for making sure my company's website is protected and it has a disaster recovery plan. Since I'm using CloudStack, so what I have is I have this instance where the website is hosted. It's a static website. So I go to this virtual machine volume, then I create a snapshot here. So as you can see here, I have 2 zones, Hyderabad and Bangalore, and this web server is running based out of the Hyderabad zone. So what do we have, the new feature in the CloudStack, right? So previously, you get an option to just take a snapshot, a volume snapshot. You just give a name, and it's assumed that the snapshot is taken at the hypervisor, and this snapshot is backed up to one of the secondary storages in your same zone. Now, you what you have here is you can choose another zone as well. So if you create a snapshot, this is copied to the Bangalore zone as well now. Bangalore as well, yes. So this will take some time. So I can show you another snapshot that was backed up previously, right? So this is available in both the zones now. So in case of any disaster, my Hyderabad zone goes down, what I can do is I can go and deploy. So, what I will do first is I will go to the snapshots, I will create a template. So, here when you create a template, you get an option to deploy this to Bangalore as well. For this demo, what I have done is I have created a template. I have an instance as well, that you can see here. So, this is a template that I have already created in the Bangalore zone. So, in case of a disaster, I can deploy an instance from this template to the Bangalore zone. So, this is my website running from this instance. So, in case my this virtual machine crashes or this data center is affected for some reason, maybe the network there is an outage in the ISP for whatever reason, what I can do is I can simply go to this my DNS, add the corresponding IP over there and make the corresponding changes. And after you have done that, based on your DNS providers, or how you have configured it, based on after you have TTL has expired, you should be able to access your new website from the other location. Now, as a system admin, I don't want to do this manually all the time, right? So, like we already have for regular volume snapshot, we have a policy based snapshot as well. So, I can set a policy to create the snapshots hourly and keep a certain number of you can set a retention number as well. So, mine is a static website. So, I do not have to have the most recent data. I am okay with getting a data up to last 1 hour. So, next we have the CloudStack Object Storage Framework. Before getting into more details on the CloudStack Object Storage, in CloudStack, if you look at the current storage before 4.19, we have primary storage and secondary storage. Primary storage where you use this primary storage for your virtual machine root volumes and data volumes, and primary storage can be any storage that is supported by your hypervisor. It could be mostly people use NFS, it could be iSCSI, it could be FC, and it could be any managed storage that is supported by CloudStack. And we have secondary storage for storing your large snapshot backup templates and ISOs and so on. But this does not solve all the data requirement that you have in a typical cloud. So, we always use object storages by different vendors, hyperscalers and so on, for storing and accessing our unstructured data. With CloudStack, people have been anyway using object storages, just that they were used independently. Now, with this object storage framework, CloudStack provides you a integration between them, and you can manage the life cycle of the object storage, the buckets, just that a few things are still outside the framework that you need to take care using your object storage provider itself. Now, why this framework is important, right? CloudStack has been always agnostic to different vendors and many technologies like the hypervisor, if you see, right. So, requirements could be different for each one of us. Somebody wants to store critical data, somebody may just want to store some test data, right, and somebody may be able to pay for large storage vendor and get some support as well. Others may just need to get some locally available hardware, install some community software and use that as an object storage. So, this plugin framework allows you to use any type of object storage that you have, okay, just that the initial release of this in 4.19 comes with the support for MinIO. So, In addition to this, Abhishek already talked about, in the community, there's already an effort going on with respect to adding Ceph-based object storage, and I believe Huawei OBS is being added, and I believe more people will see this as an opportunity and add a plugin to CloudStack for adding their object storage in the object storage providers. So let me show. Okay, I have MinIO set up here. So the installation part, you can go to MinIO and find out. So I have this already running here with a few buckets added. So if you are an operator or admin, and your MinIO setup is already done, you might want to log in as admin over here. As you can see, under the infrastructure tab, we have a new item here, that is the object storage. So like I said, CloudStack provides you a way to manage your object storage buckets through the same interface. You don't have, you can give the same experience whichever object storage that you are using. To manage the lifecycle object storage itself, you can add the object storage here, and you can enter the URL, and I have added 2 object storages already here. So as a user, if you are logging into your CloudStack, you will be typically doing these operations, right? So you will be adding a bucket. Now, what all providers do I have? I mean, both are based on MinIO, but still I have 2 object storages I can choose from. I can create I can mention a quota for this one. I can enable the versioning, and I can enable the object locking as well. There are 2 policies that is available, that is public or private. By default, it will be private. I'm making it as so my bucket is created here. This is created in the MinIO one. So you can see here my demo bucket is created here. Now what do I want to do? So we have a lot of unstructured data, maybe images that you want to access from applications hosted in your cloud. It could be some other files. Maybe you want to upload and access these data from your client side as well. So with this release, we have a object storage browser as well, so which is easy to use. You select your file. So I have few files already here. I believe it's getting uploaded, maybe there is a delay. It's uploading, right? Yeah, it's a small file itself. Yeah, so it got uploaded. Maybe the previous one had some error. Your data still goes directly to the MinIO here. CloudStack is not in the data part. Okay, so CloudStack gives you the data management options where you get the UI, and you can, when you're using with MinIO you have a separate CLI as well that you can use. And AWS S3 CLI itself you can use if you are familiar with that. then you can access this URL. If you are used to other S3 object storage solution, you can create a pre-signed URL as well, and you can use it elsewhere. Being a first-class feature in a CloudStack, this is you get usage metric and everything that you get out of most of the features in CloudStack. So you can see the metric details such as the size of it and created and updated and so on. Being a very fast release of this feature with CloudStack in 4.19, although many features are functional and working, few things such as different versions are not listed here. So as a community, I believe we have to work together to improve it and make it usable for all of us and meet our expectations. But all these like versioning everything, you can use it in any way. They are still there. If you access the min.io, you can see these are available here. So I believe I've covered all of it. Yeah, few features. I believe you have read that, like multi-part upload. These are part of the min.io object storage itself. So all those which are part of the min.io implementation, you will be able to use them.
Hello everyone, I'm Vishesh. I'm a software engineer at ShapeBlue. I started working with CloudStack recently. This is a little bit about myself. I'll be demoing about CloudStack DRS and VM scheduling. So let's talk about CloudStack DRS. So it's a new feature which automatically helps you live migrate instances across different hosts in the cluster to either ensure that you have uniform workload on all of your hosts or to reduce the number of hosts which are in use. During the demo, we'll talk about how does this help you out, and yeah. Before we begin, let's go through some of the global settings that DRS provides. For that, we can go under global settings, miscellaneous, and all the DRS related global settings are here. So DRS algorithm helps you select which algorithm to execute on the cluster. There are two algorithms available. One is balanced, other is condensed. Balanced helps you live migrate instances so that your workload is uniform across all hosts, and whereas condensed helps you live migrate instances so that number of hosts which are in use are minimal. You can also enable automatic DRS, and this basically executes DRS at regular intervals, which can be controlled using DRS automatic interval. And DRS imbalance is the metric through which we configure how much imbalance can be allowed on a cluster. For example, in case of balanced, 100% means that it will try to live migrate all the resources such that the cluster is as uniform as it can be, whereas setting it to 0% means it's as good as disabling DRS. And in case of condensed algorithm, 100% means it will minimize the number of hosts as much as it can. The next one is DRS max migrations. This controls the number of maximum migrations that we can execute on a cluster in a single DRS execution. Setting this value to too high can cause issues in case of if there are too many migrations, it can keep up all the threads on the management server itself. And the last one is the DRS metric, which decides on which metric should we perform the DRS on. Okay, so for the purpose of this demo, I have already created one cluster with 4 hosts and 4 instances. As you can see, all of the instances are running on host 1 right now. Okay, so let's see balanced algorithm in action. You can also configure DRS for a specific cluster through the DRS by searching for DRS settings here and perform that. For this demo, I'll set this value to 1.0 so that the cluster is completely balanced or completely condensed depending on the algorithm. Now let's click on generate DRS plan to generate the plan. As you can see, it's migrating 3 VMs from host 1 to different hosts in the cluster, right? So let's execute it. It will take a couple of minutes for the execution to complete. Meanwhile, balanced algorithm is useful because it reduces the number of VMs running on a single host. So for production environment, it helps you reduce resource contention on the host, and let's say if one of the hosts goes down, so the number of VMs which get impacted are minimal as well. So this helps you reduce failover issues and have better reliability in this scenario. This is still in progress, and you can also track the events here for the DRS operation. As you can see, it says that migration has been completed. So the DRS execution is also completed, I guess. Yeah. So now let's go to the instances page and see the current distribution of hosts. As you can see, each instance is on a different host right now, right?
Let's say if these were like web servers, right?
Mm-hmm.
You have these 4 instances. Now, do you migrate all of these at once, or these are done sequentially or done?
So these are live migrated. So there's very minimal downtime, but yeah, these are live migrated all at once as of now. So now let's see condensed algorithm in action. For this, let's set the DRS algorithm to condensed. Oh, sorry.
How does CD?
Condensed, yeah. Okay, now let's generate a plan. As you can see now, it's migrating all of the instances to host 4 in this scenario. Let's execute this. So condensed algorithm is useful in scenarios where you don't need that much of reliability, but this can help you save some power cost as well, because the number of hosts which are in use are minimal now. There are a lot of hosts which are not in use. So if you have configured their power settings correctly, they will consume less electricity and thus saving some power costs. In future, we can also turn these hosts down and bring them up whenever required. So this can help us save some cost here. This is similar to VMware DPS, which is I think paid solution by VMware. I think everything is paid by VMware now. Yeah, it's completed. Okay, looks like one of the migrations failed. But yeah, as you can see, it migrated all 3 instances to host 4 and one which failed. It's still there on host 1, but it's still running. So this is a comparison between balanced and condensed algorithms, the algorithms which are available for DRS. You can go through these, and as I said earlier, right, balance will lead to higher power consumption because more number of hosts are in use, whereas for condensed, because number of hosts which are in use are less, it consumes lower power. So balance is more ideal for production environments where reliability is a big concern, but condensed can easily be used for staging and testing environments. Moving on to the next feature, which is VM scheduling. This feature is also added in CloudStack 4.19. This helps you schedule different lifecycle operations on a VM, like start, stop, reboot, right? And you can also use a cron format to schedule these. Let's see this in action now. Let's select any instance here, right? And let's go to the schedules here, and you can add a schedule. You can leave the description empty and it will automatically generate the description based on the action and the schedule. For this demo, let's stop the instance at every 1 minute, which is the default here. If you select advanced mode, you can also enter specifically cron, any specific cron, like for example this, and it will also give you a basic idea of what's it doing exactly. But for this demo, let's do it for every 1 minute. Time zone is the time zone at which the cron will get executed. Let's say if you set the cron to be executed every day at 5 a.m. and then it will execute the at 5 a.m. for this time zone, which is UTC here. Next is start date and end time. So this is the time during which this schedule will be active. Let's say that you have a sale coming up and you want to, for whatsoever reasons, do multiple operations on this instance, like start, stop, and reboot. You can set the start date and end date, and the schedule will work only between those periods. For this, let's leave it as empty now. Okay. So this has been created. By default, the start date for the schedule is the current time plus 1 minute, so that it doesn't cause any conflicts whenever you do anything. So it will take at least 2 minutes to get started. You can also create multiple schedules here. For example, I can also create a start schedule for every 5 minutes and 10 minutes or anything. And in case of a conflict, the schedule which was created first takes precedence. So let's say if I create another schedule which says start every 1 minute, it will get ignored because this schedule was created first, and it will take more precedence. So yeah, we'll need to wait for a minute or two. So this schedule feature can also be really useful if you want to, let's say, start an instance at night and stop it at morning or vice versa. You can create two schedules which starts the instance and then stops the instance. So this helps you like really reduce the workload that's currently running in production as well, and schedule different operations that you want as well. Okay, it's taking some time.
Vishesh,
Yes.
if I may ask a question
Yes.
for this. CloudStack has an excellent API and automation.
Yes.
So one can use CloudMonkey or CLI to do this, and basically run the script in a cron job on their Linux machine.
Yeah, they can.
So why this feature? Why not just use CloudMonkey for something like this?
You can use that, but then you need to manage that instance as well. And let's say that your instance gets stopped. How will you detect that who stopped that instance or from where did it get stopped? So it's easier to manage all the events here itself. So yeah. Now as you can see, the instance is in stopping state, and in the events you can see that it got scheduled here and it got completed at this time, and every detail is here.
Thank you all.